Imagine a line invisible to the eye stretching across the vast expanse of the Indonesian archipelago. A line that defines where certain animals roam and others do not. This line, seemingly arbitrary, has shaped ecosystems and evolution, a boundary that has perplexed scientists for generations. This is the Wallace Line. Named after the British naturalist Alfred Russel Wallace, this line traces a biogeographical division between the animals of Southeast Asia and Australasia. On one side, we find creatures familiar to Asia, tigers, monkeys, and elephants. Cross to the other, and we enter a world inhabited by marsupials, cockatoos, and tree kangaroos. But how could such a line, invisible in every sense, have such a profound impact on the diversity of life? The discovery of the Wallace Line. In the mid-19th century, Wallace embarked on a monumental journey through the Malay archipelago. As he observed the local fauna, a curious pattern began to emerge. While islands like Borneo and Sumatra teemed with wildlife of mainland Asia, just a short distance away on islands like Lombok and Sulawesi, we found an entirely different set of creatures, more similar to those in Australia. This discovery became the foundation of what would later be known as the Wallace Line. The Wallace Line runs between Bali and Lombok, Borneo and Sulawesi, and through the Philippines. It marks a biogeographical divide that is rooted in deep geological history. Millions of years ago, tectonic plates shifted, oceans rose and fell, and as a result, the islands on either side of this line remained isolated from each other. This isolation allowed species on either side to evolve independently, leading to striking differences that we observe today. The mystery behind the Wallace Line. One might wonder, how could a narrow stretch of water maintain such a stark divide in wildlife? The answer lies beneath the waves. Between the islands of Bali and Lombok, the sleep plunges into a deep ocean trench. This trench, a remnant of tectonic activity, created a barrier that many species could not cross, effectively segregating the fauna of Asia and Australasia. Over time, this isolation led to unique evolutionary pathways on either side of the divide. Wallace's legacy and the modern understanding of biogeography. Today, the Wallace Line is more than just a boundary. It's a symbol of the intricate relationship between geography and biology. Wallace's work laid the groundwork for the field of biogeography, influencing not only Charles Darwin but generations of scientists to come. His findings remind us that life is shaped not only by time but by place. And if you've enjoyed this journey through one of nature's most fascinating boundaries, make sure to like this video. Share your thoughts in the comments and subscribe to the channel for more explorations into the natural world. Your support helps us continue to uncover these captivating stories. The importance of conservation on both sides of the Wallace Line. Though the Wallace Line has existed for millions of years, human activity is rapidly changing the ecosystem on both sides. Deforestation, climate change, and habitat destruction are eroding the natural barriers that kept these unique species separate. Conservation efforts today are more critical than ever to protect the biodiversity that thrives on either side of the Wallace Line. The Wallace Line is not just a line on the map. It's a testament to our power of isolation, evolution, and the fragile balance of nature. As we continue to explore our world, it's important to remember that every invisible boundary tells us a story. One of life, change, and the intricate web that connects all living things. Thank you for watching, stay curious, and we'll see you in the next video.